All right, Larry, thanks for joining me here to demonstrate our integration with Iceberg really quickly. It seems like you're going to start with static Iceberg or data at rest and then go into some sort of refreshing version where an update or new data sort of automatically comes in through the integration. Yeah?
That's correct.
All right, let's have at it.
Okay, so I've got some local data on a MinIO instance here. So that's, you'll be seeing the data is hosted locally, but all this would also work with any kind of cloud hosted Iceberg. But this is setting up an adapter which will create and connect to the catalog using the S3 Parquet files. So I'm going to create an adapter. And then this adapter is what I'll use to reach out and list the namespaces, list the tables within a namespace, and list snapshots within a table. Because we love tables at Deephaven, here is some calls that'll actually bring in the namespaces from the catalog as a table, the tables within the sales namespace, and then snapshots within the sales multi-table right here. So we can see we actually have 6 different snapshots pre-created. And in our static demonstration, what you can actually do is you can specify and bring in any particular snapshot as a static Deephaven table. So I'm going to be building this S3 instructions and Iceberg instructions object to provide to our catalog just more information on where the data is stored. Let me bring in those. Okay. So here's some other tables. It's the same data, I just have it kind of different formats. Here's a table that has a sales information. It's 100,000 rows. This is just on the S3 storage. It's a single Parquet file with 100,000 rows. And then I have the partition version of this, which interacts really well with Deephaven's view of partitioning data. And
can you just hit that? Can you full screen this view here? So just hit that square just to the right of that.
Oh,
that one, yeah.
Okay.
And then maybe just like pick a few different partitions or show the keys or something.
Yeah. So there's not a lot of keys here. I just have a kind of a simple set of data. Yep. But the important thing is, this is showing 36,000 rows, and our other partition is the other 63,000. Together they sum to make the 100,000 rows, and I could show that as well. So
yeah, cool.
Our partitioning tools are actually pretty good.
Yeah.
All right. What's kind of interesting though is this, when we want to think of Iceberg as a series of snapshots. So I'm going to call a slightly different version of this list snapshots that'll actually just bring in the IDs of the different snapshots. And these IDs are long values that help it, that are used to actually identify uniquely each snapshot within the table. And I can I'll bring all 3 of these at once, but these are 3 different snapshots of the same table. This, by specifying a snapshot ID, it'll load that particular snapshot, bring it in as a Deephaven table named multi-0, similar with multi-1. And then when I'm not specifying a snapshot, as I didn't in the earlier tables, it'll bring in the latest. So let's just run all 3 of these at once. Okay, so here's a couple more tables. The first snapshot has 18,000 rows. This one should have 100,000 rows. And then the latest actually has 0 rows, but that's just showing we performed a delete, and that actually will demonstrate how that works. I'm going to clean some of this up. But is there any question about static tables before I move on and show some of our refreshing data?
We can move on.
Okay. Some of the other stuff we allowed to do, I demoed this before, but you can do renames in your tables, also specify custom table definitions if you want to exclude columns, but I don't need to demo that again. All right, so this is the auto refreshing version. And the idea of this is we basically create a Deephaven table that is a ticking table that will automatically be reloaded when any changes to the Iceberg table occur. So what I am going to show you, I'm actually going to bring in this Jupyter notebook I have that's going to drop this table and then rebuild it row by row. So the first thing I'm going to do is just create the database. It does already exist. And
So
I'm gonna
this
drop.
Jupyter notebook is just, you're sort of pretending to be an application outside of Iceberg and outside of Deephaven, yeah?
Correct.
Yeah.
Yeah. So this is just forcing changes into the Iceberg data. This is entirely outside of Deephaven. I'm
Right.
just making these changes in the catalog. Underlying catalog will reflect this stuff. Okay, so I'm loading some data from disk. I'm going to display it. This is a Parquet file, and here's what the data looks like. It's similar to what we've seen. And now, after I call this next cell, this is what will actually write down our first single partition to Iceberg. So this will basically create the table, write a partition to disk, and then at that point, it's a valid. Let me just do this again. Okay. All right, let's run this from the top. I think it has enough time to drop my data. Okay, there we go.
There you go.
So when I go back into my table here, what I'm going to do is, okay, none of this is particularly different. Loading an adapter, creating the instructions, Iceberg instructions, but this is where things get more different. I'm specifying that this Iceberg table I want to load, I want it to automatically refresh. And I'm specifying a very fast refresh interval. So every 1,000 milliseconds, every 1 second, it'll reload, it'll request the Iceberg catalog and check for changes to this table. So I'm going to go ahead and
if there's no changes, it does nothing?
Correct. Mm-hmm. Yeah, there's no downstream changes.
Yeah.
Okay, so here is a table, 18,000 rows, and probably before I can even switch back over, when I run this next write, so this will add a partition and create a snapshot. And I'll snap back over. Oh, I didn't do the interesting part. I didn't actually add the listener to show that the table has definitely changed, mm-hmm. but I should have connected this listener so we can actually see some motivations. And actually, there's a little summary table that'll show the number of rows and some summary information, so you can see that downstream tables that are doing the summation are affected by the
Can you just put like sales multi summary, like just drag it down so it's in screen at the same time as sales multi? Just drag it. Yeah, there. That's fine. Either way. So you're seeing them both. Yeah. So essentially, when you go to the other application, you add new partitions without you touching the screen or doing anything. Things should update, right? So the sales multi table that is sort of the source table that's incrementally updating from or refreshing via Iceberg will change, but so will this second node in the DAG, right? This dependent sales multi summary table that you've created.
Right. Yeah. And this is demonstrating that we're not, invalidating the previous table. We're actually performing, a limited update to it.
Yeah. Okay.
Okay. So let's execute the next one. And switching over, here's what I wanted to show the first time. Now there's a total of 72,000 rows, and the most recent transaction added 18,000 rows. Here's the total row count as well, and this data has changed.
Right.
Without any interaction. Yep. And then another write. This should bring us to our total of 100,000 rows. We have new data here, and this also reflects 100,000 rows. So this is a simulation of like a set of append-only events that would go into Iceberg. And so these are responding, and we're getting all the data. The next thing that's kind of interesting is Iceberg allows like a compaction event. And the effect that has is to rewrite all of your existing partitions or some subset of your partitions into a single partition for better data access. So the way it looks like, well, let me just execute it and we'll talk about the way it looks like to Deephaven. All right, switching over. So Deephaven sees this compaction event. We removed 4 data files and added 1 back in. So it actually sees 100,000 removed records, 100,000 new records. But since these all contain the exact same data, then all of our aggregations are absolutely correct. And if you really want to get into the weeds, we actually can see how there were 4 row key partitions that once this update has gone through are now into one single key space.
Got it.
And then a final thing, just to bring it back to our our start is just deleting all the rows. And what this does is actually removes every data file, and it's something that Deephaven can also handle. There's 100,000 removed rows, removed our keys, and all of our stuff is back to zero. All right, any questions on auto refreshing?
No, that seems it seems pretty powerful. It seems
Right.
very exciting. Is there what features are on the horizon for you, or what other things related to the integration excite you?
There actually is another feature I can show of this, which is if you want exact control of your updates rather than just allowing it to go on a wall calendar. If you want to even control it maybe externally to Deephaven and not just have a 15-second or 60-second timer, there's the idea of bringing in these snapshots one at a time. And so the sales multi table is, maybe I could just run this real quick. Let's bring it back to here. And so here we'll be able to see the data update in real time, but we are at the state where our sales multi is at our first snapshot. And so
you're saying, just to be clear, you're saying these, like we just saw you via the Jupyter Notebook create these respective partitions, right? So they exist, and you're just saying instead of bringing them in sort of on this 1-second timer that's listening from Deephaven to Iceberg, you're saying they naturally exist and you can control when they're brought into the Deephaven framework.
Correct.
Yeah, okay.
So we're starting with like what exists in our first snapshot, and I'm just going to add a set of records here, and we'll see that, okay, this changed and our data changed. I'm going to make the point here to not execute this snapshot and just show you how we don't have to progress snapshot by snapshot to get a complete view of the table. By skipping snapshot 2 doesn't matter because all the data will still be contained in snapshot 3, and Deephaven will see we'll see a larger set of added rows. All the data is still correct. The downstream data, the downstream DAG table still has exactly the same data that it should have at this point in time.
But it really just brought in the ads, essentially the ads related to what you're calling snapshot ID 2 and 3, even though you only called for 3.
Well, yes. It's a little more sophisticated than that in the sense that if something was added in snapshot 2 and then removed in snapshot 3, we never make the effort to bring it in when we know we're going to drop it.
Interesting.
So it's more like a diff between the snapshot that I'm on and the snapshot that I'm going to.
Got it.
And we bring in those data files. And here's a compaction event where this data should be complete. We got the full 100,000 rows, and we're going to be removing 100,000 rows, adding 100,000 rows, and our summary data did not change at all.
And to be clear, that diff calculation or the metadata to support that diff is really Iceberg technology you've integrated with, not you're not like reading it into memory somewhere, doing the diff and then bringing it into Deephaven per this table. It's all happening sort of at the storage layer.
Right.
Yeah, cool.
Right. Yeah, the Iceberg metadata contains a list of the data files that are present in the snapshot, and we actually do our diffing against that, and we don't have to dig too deeply into what was removed on this snapshot versus the previous because we can just take a more macro view of it.
Cool.
2 more snapshots. This one is just kind of interesting because it drops everything down to 0 and we see all this disappear in real time. And then the other one is just what happens if you try to request snapshots out of sequence. Now, what I mean is not by skipping a sequence, but actually going in the wrong order. We only allow historically increasing tables, snapshot IDs.
Got it.
So,
and somewhat that's because that's the way Iceberg is organized, I'm assuming.
That's correct.
Yeah, okay.
Yeah. Yeah, Iceberg, I mean, it does have a continuity, it does have a history, but also is kind of a series of snapshots. And so it's not technically impossible, to consider like to diff for the future against the past.
I assume there's timestamp. Does the metadata support timestamps of the snapshots so that you could sort of recreate point in time pretty easily through this type of technology?
Yes, let me bring in. So These were all created, within, a couple milliseconds of it, but these are unique timestamps encoded in the metadata for each snapshot. So I'm not absolutely positive, is this from the epoch or, what does it relate to? But the data is there. And, with a little work or a little discovery, you could definitely query a snapshot as of a given time.
Yeah, and Deephaven's pretty strong at time manipulations, so to speak. So, it'd be pretty easy to reconstruct point in time, largely relying on the partitions in the Iceberg storage, but also whatever within a partition, just the as of joins or as of statefulness in aggregations that could be created through the Deephaven engine, I think would be pretty powerful.
Yeah.
All right, very cool. Anything else Icebergy to advertise or foreshadow?
No, I think this is a pretty cool technology demonstration. Looking forward to adding this type of integration for other cloud systems as well.
Yeah, we're excited. Good stuff. Thanks so much, Larry. Appreciate it.